All right. Hi, everybody. My name is Jonathan Parsons. I'm the co-founder and CEO of Cognitive Automation Labs. So I co-founded CA Labs with Tylor Bunting. And so essentially CA Labs is a boutique AI and automation company that helps enterprises transform themselves, focusing on their core digital value chains and then leveraging emerging tech to essentially digitize those processes. And so in terms of kind of content today, or a bit of background about myself, so I've got 15 years experience. Previously was working as a senior manager in the digital emerging tech advisory space at EY, which is kind of where I met Tylor as well. And essentially we're driving transformation across finance, banking sectors, petrochem sectors, spent a bit of time in the education sector as well. And now kind of starting to dabble a little bit in the legal sector, given that we think kind of the technology and timing is right. And so today's presentation really is going to focus on, in our view, defining what AI native businesses are, what they look like, speaking about the factors driving the legal revolution at the moment, and driving the transformation in the legal sector, and then really driving and then kind of jumping into the economics of that. And I think a lot of questions saying, how much does this actually cost? And we'll kind of start jumping into a bit of the details around that as well. And then Tylor will give us a really good demo. He's actually been in the background getting the last bit of codes updates done in the background. It's done and dusted, so we'll have a good demo today as well. And then we'll close out for any questions. And so jumping into defining what is AI native, and in our view, essentially an AI native business, and a lot of people dabble in AI and they deploy solutions in terms of invoice processing or kind of onboarding, but really where you're changing the game is when you look at a company and look at its core operations, its reason for existence. And if you're starting to digitize those services in terms of why a company exists, that's where you start to shift the dial and move a company to becoming a more AI native approach. So looking at those core value chains, leveraging AI for the decisional kind of decisional logic around that, and then leveraging kind of high speed real-time automation to kind of sync that together. And you might be using machine vision to look at documents, classify document types, extract information, to potentially understanding kind of and routing of emails in terms of their subjects and kind of body. And so kind of using that whole cohesive suite to create digital service value chains within companies. And so in terms of looking at what a non-AI native business looks like. So companies today, traditionally, for every dollar that they're spending on average, they're going to be spending about 65 cents on operating cost of that company. And so when you get into the details of the value chains of these companies, it's a mesh of a whole bunch of ERPs and enterprise resource systems, sales management systems, and it's all glued together through emails, humans moving information around in a very disparate way. And the problem with that is it's not necessarily scalable, and it's really expensive. And so when you scale companies like this, the operating cost, although you might get some forms of efficiency, generally your operating cost scales out quite significantly as you scale the revenue of those companies as well. And so you don't have a lot of capacity to hire people in terms of more strategic thinking and building the machine as opposed to kind of working in the machine. And so when you move towards a more AI native business, essentially what you're doing is saying, let's look at where we're doing execution, see how we can kind of digitize that through forms of AI and automation, and then uplift everybody's job to take on a more strategic focus going forward. And generally what happens then is you kind of drop your operating costs by generally a factor of a third. And you create this really scalable kind of system that as your revenue scales, and you can dynamically scale your operations down to kind of 10 clients or up to 100 million clients if you want to. It really doesn't matter. It's just, you really just need to turn the dial to kind of get the level of operation capacity that you need. And so a good example of this is kind of if you look at a few companies and say which companies are really kind of AI native or tending towards AI native versus kind of more traditional operating models. And one of the ways I like to look at companies is to say, all right, if I take a company's revenue and I divide it by the number of employees that that company has, it's a good indication of the value that's being generated per employee. So it's kind of a GDP per capita kind of analogy. And so if you take a company like Microsoft, and these are the figures for 2022, they generated about 198 billion US dollars, and they had 221,000 employees globally. And so if you look at the average kind of revenue per employee, you're looking at around $895,000 per employee, which is quite significant. Similarly, on the front of on Google's side as well, they've staffed up quite significantly. I think they've added about 20-30% to the capacity compared to 2021. But they generated $282 billion and they've got 190,000 employees. So they are generating on average about $1.48 million per employee, which is significant. And the reason why they can pay such high salaries and offer such ridiculous retention bonuses. And then so typically a more traditional firm is where I kind of worked for a good amount of time. Somebody like EY in 2022, they generated about $45 billion with 365,000 employees, almost double what a Microsoft, what kind of Google has. Yet they're only generating a fraction of that. So it's kind of a factor of 10 out, which is quite significant. And I think that's the real kind of key difference when you kind of start to really integrate software in terms of the value of your services. You can really add significantly more value with the same kind of number of employees. And so taking this towards the legal sector, which has largely remained unchanged for the past kind of 50 years. And I think we're now at this point where things are starting to change. And a good indication of this was a report that was released by Goldman Sachs on the 26th of March. And they basically took the US job market and they divided it down into the various sectors in terms of kind of the industries. And they said, for each of these sectors in the industry, they then analyzed and said, what is the percentage automatability of all the tasks within that kind of industry? And so, to no surprise, office administration, one of the highest, came out at 46%. So highly automatable space, and I think we all kind of knew that. And on the other hand, like where it's really unautomatable is kind of building grounds, cleaning and maintenance. This is something that requires physical effort. And that's really hard to automate because you actually need a physical device to do that. And obviously companies like Tesla, they're building their own robots now and aiming to kind of focus on that market using kind of the knowledge that they've learned in terms of autonomous driving. But it's really difficult to do. And so definitely not that automatable. But at the same time, next to, on the other end again, next to office administration, the next most automatable industry was the legal sector, sitting at around 44%. And the question is, why now? And I think we've all been kind of chatting around that today. It's really large language models are a game changer. So law traditionally, I think, has been a profession of words. And so in the past, for computers to deal with words and grammar and context has been extremely difficult. And most of the kind of legal tech that we've seen up to this point has really steered away from trying to actually work with words and context and focus on kind of other areas around that. But I think with the advent of these large language models and specifically kind of GPT-4, GPT-4 is really, really good with words and is quite a game changer now in terms of kind of where we are. But that alone is not enough. And I think the other advancements that we're seeing now is massive advancements in multimodal cognitive search. And so what that means is basically, and to Alan's kind of demos, you can take words and get images out. But conversely, you can also go the other way around. You can put video in and get transcription straight out, very close to kind of what everybody is saying. And you can also get detailed analytics of what's seen in those videos as well. So you can take all this multimodal data, convert it back to text, which these LLMs can then use to process. And in conjunction with that, on the automation side, we've had massive cost reductions in terms of the actual automation technology, which stitches everything together. And so essentially what's happened is Microsoft and Google have started to create these accelerator frameworks, which Tylor will be demoing shortly. But essentially it combines basically these two technologies, Azure Cognitive Search with Azure OpenAI. And essentially the vectorized databases that Tony was talking about, you can kind of put your precedents into that vectorized database, and you can have a user query that through your Azure Cognitive Search and basically ground that information to the data set that you want and get the various citations that you need, which I think largely helps in terms of the hallucination effect. So you can start to ground those responses in the data set that you're looking for, as well as get the citations to the relevant pieces of information that vouch for that data and kind of back up that data, which I think is a significant kind of differential to kind of what we see today in the open source kind of clouds based versions of OpenAI and kind of Bing. And so in terms of the economics around that, so technically, yes, it's feasible, but does it make business sense to do that? And in terms of automation costs, from what we've seen, first generation automation typically was only able to be kind of implemented at large ASX companies, so your top 100. But now with automation, we've had a reduction in cost of around 70 to 90%. And so that really opens up the door to even mid-size companies to start deploying automation within their operations. And so that, from a cost perspective, has really opened up the door going forward as well. And this slide I put in as well, chatting to kind of David over the past few weeks. A lot of kind of owners of their companies, they think about automation as reducing cost, increasing efficiencies within their system. But also when it comes time to kind of sell your business and value your business, which is, I think, as a role of a CEO, you're really trying to drive up the market value of your company as well. By digitizing your processes, investors know that your business becomes almost infinitely more scalable and can operate at a fraction of the cost. So the price that they're willing to pay for that business, that digitized service, is significantly more as well. So the graph here kind of shows companies based on the x-axis. You've kind of got revenue of a company versus the valuation of the company as well. And so as you digitize your process, you go through these digitization events, you can start to sell your business where traditionally you might sell it for 1.5 price to earnings or price to revenue. But as you digitize, that jumps up 2 times, 3 times, 4 times, even maybe you get to 8 times multiples in terms of your company as you digitize your process. So 1.5 to 8 times is a significant increase in the market cap of your company by a factor of 6 or 7, which is quite significant. And in terms of approaches, so how do you actually go about doing this? There's 2 ways to do this. If you're a really big enterprise company, you might decide to build an AI center of excellence within your company and use it as a bit of a factory to digitize your processes. It's quite expensive, but it works out. It's cost effective for really big companies that have just hundreds and hundreds of processes. But to set up a COE, you're looking at just short of $1 million to hire all the relevant teams. And then typically the break-even point for that is only in your kind of year 2 horizon. However, with kind of the advancements in technology, everything moving to the cloud, it's significantly easier to kind of just use AI and automation as a service. And so you might have 1 or 2 processes within your business that you think, man, if I could just really digitize this, I could save a significant chunk of capital in terms of labor. And so in kind of the new mode for automation and AI as a service. You have vendors kind of coming in, typically looking for where they can kind of save a company about 100K per year, and looking from a technical viability perspective, something that costs around 45K per year to develop, and then kind of keep the lights on for another kind of 2K per month, or kind of 24K per year. And so that AI as a service is becoming a more predominant approach for kind of the mid-tier market, and helping kind of businesses become really scalable. And so I'll kind of leave it at that point and start handing over to Tylor to do a bit of a demo to kind of showcase the framework that we were talking about, leveraging cognitive services and OpenAI to provide some natural responses based on a specific data set. Over to you, TB.
Testing. Excellent. Thanks, JP. So firstly, you see a QR code up here. So feel free to get your phones out, get the QR code connection going. That'll essentially link you to a website at lawtech.calab.ai, and that is the app we'll be using for the demo today. Do you want to pull it up? So the slides that JP had up earlier, you would have seen there was a specific solution diagram which showed the flow of an enterprise chat GTP solution that was integrating and interacting with enterprise data. So what that means is essentially we've got a set of different types of data sources. Maybe it's a semantic DB where we have different types of keywords mapped out and links so that ChatGPT can go and search for those. Maybe it's just simply a OneDrive. You've got a bunch of files stored in your OneDrive and you want to make those searchable and so that ChatGPT can interact with it. And those are some of the type of data sources that you can coordinate so that a ChatGPT interactive solution has access to those. What we can see here with this demo, and if you do have it on your phone, I highly recommend you go on that mode. Yeah, landscape. Thank you very much. Because there is some forms of interactions which you want that view. It's not highly mobile optimized. It's mainly optimized for this demo. Cool. So you can see here there's a bunch of different questions that we've got here which are set up as kind of just demonstration questions so you can interact with this app. It's a functional app in terms of what it's set up to do. We've just got a bunch of different CA Labs policies and procedures that have been indexed using Azure Cognitive Search. And when you're talking and interacting with this version of ChatGPT, it understands how to search for those. And where things get really interesting with these enterprise-grade ChatGPT solutions is when you're plugging in these different types of functionalities. So at the moment, we've got it set up so we can search through a corpus of policies and procedures. But you can also set up these types of solutions. So they have other functionalities like sending emails, or maybe you have a reference of maybe you have a specific internal system which has all of your case law documents, but it's in a database, and you might want to ask ChatGPT something and then go and update that case management system. So actually log in the back end, use some of these technologies that JP was talking about previously, the automation technologies, to actually do things so that the humans wouldn't need to do them, like logging into an application and proceeding with some type of activity. So for those who don't already have it up on their phone and aren't playing with it, we'll give a little demo here. And as I mentioned, we've got the CA Labs policies procedures just trained on the back end of this. And we'll just ask a simple question: what happens in a performance review at Cognitive Automation Labs? So you can see here it's got a response for us. It's brought together essentially a bunch of information relevant to two things. One, we've got prompt engineering that's configured on the back of this. And two, we've got that search index. And the search index, does everyone know what I'm talking about when I say search index? If you go on Google and you search something, that's a search index that Google's built up. And so when you're searching keywords, it's got that knowledge on what you might actually be looking for. So if we click on this citation that it's brought together, it's going to show us this reference document. And if we just ask something simple like, tell me more, it's going to go ahead, research for relevant documents, based on the index functionality. Provide an additional citation, and you can see here that it's reading the contents of the document as well as providing that relevant information. Cool. So how does this work? If you go to the thought process here, you can see that there's a conversation trail that's happening here, and you didn't see me type any of that information. So you can see the initial prompt here is actually assistant helps with company employees with policy information related to cognitive automation labs. Be brief in your answers, and you can see how there's a bunch of instructions in that. So what you're looking at there is something called prompt engineering. I'm sure it's been spoken about already today. Apologies, I was working on the demo, so I haven't seen all of the presentations. But prompt engineering is the mechanism we're leveraging here to optimize the result that we want to see. The other method that you can use is fine-tuning. The difference between the two is prompt engineering, you're really just kind of guiding the direction of the outputs, where fine-tuning, you're actually retraining the model. You might be retraining the model on specific sets of text so that the actual model has a different understanding compared to the default ChatGPT that exists. You can see here as well that what's happened is when we've gone in and we've put that initial prompt in, it's gone through and it's found a bunch of different sources. So you can see here the first source, it showed us this page here, and there was a bunch of relevant information to that. And there was a second prompt that we pushed in here. Tell me more. Great, and then it flowed through and provided that additional information. So this here as well, this isn't the ChatGPT API. For those who might not be following when that gets released as an API, it's not publicly available yet. You need a request and then you have access. So what we're actually leveraging here is essentially a method called LangChain, where we're chaining together sets of conversations. And if you could see on the back end here, of this code base, you could see that we're actually instructing it to look back at the previous conversations. Can I get a show of hands of who was here last year? LawTech? Excellent. So I did a presentation last year on a case management. So the demo I did last year was focused on more so the automation side, downloading case law documents, and then it was essentially a demonstration of how that could be automated. Where you can envision this being leveraged in combination with automation is if you've got a specific case law data source that you really want to rip down and then you want to store that and make it indexable, you can see how you can combine two solutions, one an automation solution to download a bunch of different case law examples, and then two, plug it in so it's search indexable using a solution like this. So that is essentially the overview that I want to provide on how you can mesh cognitive search in combination with a ChatGPT type solution. JP, back to you.
Yeah, thanks, Stevie. Fantastic demo. I think maybe we can, at this point, we're pretty right on time, but happy to take one or two questions. Yep.
So how have you found companies handling the security situation where not all their data is available to all employees for specific reasons, whether it's case data or whether it's sensitive performance review or HR data? Is there the ability for you to say, hey, don't show this information and or don't disclose that I'm not showing all the information either, because that in itself could be a security?
Yeah, and I think that's a great question. In terms of, I think we've been working with large enterprises, so they're taking a very cautious approach to this. And so the idea that most of them are taking is to follow a bit of a strategic approach to work with very small sets of data. So for example, they might say, let's just take all of our policies within our company and ring fence that and open that up to frameworks like this to be able to make it searchable. So yes, very cautious around opening up their data sets. They definitely ring fence the data. The call out here is that this is not going to the cloud and it's not available in the cloud. It's not something that can be exposed to the cloud because it sits within the tenant of the enterprise.
Yeah, and just to quickly jump in, so Azure Cognitive Search as well, ChatGPT, the API, and that's quite new, but cognitive search, there is functionality. It's all in the Microsoft umbrella, so access controls can be managed with that.
Speaking at that level, so more at the data level, if you provide all your policies and procedures, and some of those policies are very restrictive. For example, if you're working in an organisation that has a chief security officer, they have certain documents that are not visible to anyone other than themselves and usually a second, but that needs to go into the large language model for the training purposes, but not to disclose it in a response to anyone unless they're authorised to see that information. So more that side.
Yeah. That's where you'd probably look to leverage fine tuning, and you have separate models for different security use cases. Yeah. Thanks.
So guys, the stuff that you build, is this like a done for you model, or is this a model that the user can go in and actually drag and drop and make automations happen or whatever?
Yeah, so essentially there's accelerators and there's solutions. We just saw there was an accelerator. Accelerators are essentially code bases that we can essentially deploy solutions fast at client sites because we've got the code base and the foundation to deploy them. Where a solution is, I think what you were talking to, this is more accelerator. Yeah. Yeah. Cool.
Thanks, all.
Thanks, guys.